Hello everybody, welcome to this webinar and thank you for joining us today. I'm Simon Sherrington and I lead the GSA's research activity, and I'm going to talk to you about some work we've been doing in the area of private mobile networks, which is a new element of what is a much broader program of data collection, research and analysis that's made available to GSA members. Can you move me on to the next slide, please? To get us started, what are we talking about? Public mobile networks are self-contained networks on behalf by private and public sector organizations. By self-contained, I mean they are generally not open to the public. There are some exceptions in the case of some village or rural networks or city hotspots where some of the capacity is made available from public hotspots for local internet access, for instance. But by and large, the networks we're talking about here are for the private usage of companies and public sector organizations. And our analysis here covers private mobile networks based on LTE and 5G. We're not considering here alternative legacy technologies, of which there are a number. We're focused very much on LTE and 5G, and in the future we'll be looking at 5G standalone. So why might an organization want to deploy a private mobile network? The benefits of deploying private mobile networks based on LTE or 5G are quite varied. They can include the need to cope with spiraling volumes of traffic from mobile devices or mobile connected infrastructure, particularly when the public networks may not be configured in a way that's optimized for the needs of a single enterprise or government organization. Can help with customization. The parameters of a private mobile network can be configured and reconfigured to meet an organization's exact specifications in a way that a public mobile network often cannot. A private mobile network can offer improved access to services with mobility available in locations not reached by public mobile networks. So that might involve improved coverage indoors, in remote areas, or in underground locations. You can get improved security and data control with full separation from the wider public mobile networks, and the network user can configure security as they wish. Private mobile networks might offer improved quality of service, for instance, where license-exempt technologies such as Wi-Fi can't meet an organization's capacity, mobility, coverage, availability, latency, failover or throughput requirements. They can offer flexibility, so private mobile networks can be used in dynamic environments where equipment needs to move about and where fixed cabling either gets in the way or is costly to reconfigure or relocate. And there's also the possibility for integration with wider public mobile networks where services are required outside the private campus or regional network. That's only realistically possible through roaming into a public mobile operator's network, but the point is the underlying technologies, LTE and 5G, are common across the private and public networks, which makes that possible. Private mobile networks can deliver voice, including voice over LTE or soon, voice over new radio, text, data and video services, and can be used to connect machines, sensors, devices, computing systems, as well as people. And as a result of substantial and ongoing work by 3GPP, private mobile networks can also support mission-critical communications requirements, making them suitable as legacy LMR, PMR replacements for government and emergency service organizations. Next slide, please. The exact number of existing private mobile networks is hard to determine, as details are often not made public. GSA's undertaken some analysis to try and identify all the ones that have been publicly announced, if you like, and excluding companies holding CBRS priority access licenses in the USA, except those known to be undertaking private rather than public mobile network projects using that spectrum, and excluding more than 150 spectrum licenses in the Netherlands that are due to expire in the next couple of years and are the subject of spectrum restructuring plans, available data suggests there are at least 330 companies or organizations across 38 countries that have been or are investing in private mobile networks based on LTE or 5G in the form of trials, pilot deployments, commercial network launches, or investment in licenses that would enable deployment of private LTE or 5G networks in the future. And that's likely to be an underestimate of the global market. So in order to improve information about this market, GSA is now maintaining a database of the networks and the spectrum being used, and that database now catalogues specific information about 200 companies deploying or holding licenses. Next slide, please. So what we're going to do is talk through a little bit some of the findings that have come out of analysis of the data set that we've collected so far. And the slide here looks at how private mobile networks are being deployed. So where the information is available, GSA is tracking the technology being used for private mobile networks, LTE or 5G, and as I've already mentioned, in the future we'll look at 5G standalone technologies. It's also tracking whether networks are being deployed as pilot projects, for instance, to see how they might work in an industrial context, or whether they're being deployed in a full production environment for the long term. As mentioned before, the private networks we're looking at are based on LTE or 5G. There's a large base of customers who operate private networks on older technologies, and we're going to be monitoring whether those move over to LTE or 5G in the coming years. GSA also tracks a number of public NB-IoT and LTE-M networks being deployed for Internet of Things initiatives, and although not covered in these slides, IoT projects could be classified in the future as private networks, for instance through the use of network slicing and operators sub-licensing or of specific spectrum bands in specific locations in the future. And GSA's catalogued 110 NB-IoT and 49 LTE-M deployed networks worldwide as of mid-October, so there's a strong base of technology there that could be used. But looking at private mobile networks based on LTE and 5G today, LTE is used in 81% of the 156 private mobile network deployments for which we have data now. Perhaps surprisingly, 5G is already being deployed or planned for deployment in over a quarter of all those networks. It's not always evident whether a private mobile network deployment is intended as a pilot project only, or whether a full production network is being deployed, as the end user or the contracted vendors don't always make that information available. What GSA's data suggests, though, is that LTE deployments are much more likely to be commercial and 5G deployments are much more likely to be pilot projects at this stage. Though you should note, looking at these charts, some private mobile network projects involve both LTE and 5G being used in combination. Next slide, please. Looking next at the geographic scale of deployments, we've classified private mobile networks as either local area networks, which are single sites, or campus networks with multiple sites, or wide area networks, so regional, citywide, or national infrastructures. As might be expected, when we look at the data, local area network deployments outnumber wide area network deployments. And we probably anticipate this disparity would continue, as there are many more potential users of smaller local networks than large regional or national ones. And you can see here from the data that the local area networks account for about 2/3 of the projects for which we've managed to identify some data. The key wide area network builders are organisations like rail, utilities, or cities building smart infrastructures, where you would need a wide coverage of the infrastructure. Next slide, please. A critical factor in the delivery of a private mobile network, in the operation of a private mobile network, is the availability of spectrum. Without the spectrum, not much happens. So there are several ways that you can use spectrum to launch a private mobile network. You can use unlicensed spectrum, solutions that enable the use of LTE to build the network using spectrum that's freely available for public use, such as the spectrum bands set aside globally at 2.4 GHz and 5 GHz, but are already widely used for Wi-Fi. LTE and 5G networks can use unlicensed spectrum through various approaches, including LTE unlicensed, licensed assisted access, LTE wireless LAN link aggregation, and we have a regular report that comes out looking at the development of all those technologies on the website. Multi-fire enables the use of LTE and unlicensed or shared spectrum. And 3GPP Release 16 has introduced standards for the use of unlicensed spectrum at 5 GHz and 6 GHz for 5G networks, and it enables new modes of operation for 5G networks, including anchored NRU, license-assisted access for 5G essentially, and standalone NRU, using only unlicensed spectrum to carry the 5G service. Now, whilst use of unlicensed spectrum offers benefits, it's the case that many organizations are concerned about the risk of not being able to achieve the required system behavior, availability, and performance using unlicensed spectrum solutions. So dedicated spectrum is often required too. Shared spectrum solutions, a middle ground if you like, enable use of the same spectrum range in a single geographic area by more than one organization. And then licensed spectrum can be used where either a public operator provides a private network as a service using the spectrum it's been allocated to run the private network infrastructure, or where it subleases its spectrum to the private network operator, or alternatively where the national regulator has specifically allocated spectrum to be used for local private networks. In many countries, utilities and emergency services have historically been allocated dedicated slices of spectrum for their private networks, although many would potentially argue they don't have enough spectrum to support their future requirements and are considering hybrid models to combine public services and private assets. But with the arrival of 5G, regulators in many countries are considering allocating or are already allocating more spectrum to enable private network deployment with the aim of enabling and encouraging digital industry development. CBRS in the US is a blended approach combining shared spectrum usage with priority access licensing. Now, looking at licensed spectrum, a variety of bands have been used worldwide, and they're shown on the slide here, and more data is going to be available in our forthcoming data sets and reports. But you can see bands already in use include bands at sub 1 GHz, so 450 MHz, 700 and 900. There's the mid-band spectrum ranges between 1 and 6 GHz at 1400, 1800, 1900 MHz in Japan, 2.1, and increasingly C-band spectrum. A lot of activity in the use of C-band spectrum in Germany, for instance. CBRS spectrum is, of course, in the C-band range. And millimeter wave spectrum at 24 GHz, 28 and 37 is already being used or considered for use around the world. Millimeter wave spectrum is interesting in that it opens up the possibility for high-capacity small cells in densely populated areas, and as the chart shows, it's being made available in a variety of countries around the world, with some of the spectrum made available specifically for local networks. Some countries have made the spectrum available to public network operators, although this doesn't preclude use for a private network. It's just that the model is reliant on the public operator to facilitate local spectrum leasing, private mobile networks as a service, or exclusive usage of the spectrum in specific areas. And there are a number of countries, not plotted on the chart here, but the information is available in our report on millimeter wave spectrum, which will be coming out next month, that are currently planning to make millimeter wave spectrum available over the next couple of years. And GSA will be tracking which of those set aside specific spectrum ranges for local private mobile networks. Next slide, please. So who's deploying private mobile networks? So GSA is tracking on an ongoing basis the types of organizations gaining licenses for deployment or who have actively started deploying private mobile networks. And the chart here shows the data that we have for organizations globally. GSA's data suggests that manufacturing is an early adopter of private mobile networks. We've identified nearly 40 companies holding licenses or involved in known pilots or deployments. Utilities follow second, followed by organizations in the communications IT market, and then mining. This data is updated from the report published earlier this month and now includes an analysis of what's happening in Germany, where C-band spectrum has been made available for local broadband networks. Interestingly, the data shows that although we're talking about private networks here, public network operators are not excluded from the market. It shows that public network operators are involved in at least 20% of all the private network deployments for which we have data, There's a strong supply market too, with 26 equipment vendors actively involved in the supply of technology for private mobile networks. Next slide, please. Looking a bit more closely at Germany, where the regulator makes the data about some of its C-band local network licensees available, and where GSA has complemented this with wider research, GSA has been able to classify licensees by sector. It's important to note that identities of other licensees are not all published by the regulator due to requests for commercial confidentiality, so it only releases data about a subset of the players in the market. But as you can see from this chart, once again, manufacturing leads with the most numbers of organizations from that sector holding licenses. This perhaps no surprise given the strength of Germany's manufacturing sector and the strong potential benefits of deploying advanced LTE or 5G in factory environments for monitoring and automation. There's also been a high number of licenses awarded to organizations from the communications and IT sector, suggesting a strong base of suppliers emerging to support organizations that don't have the skills to deploy their own private networks. And I suspect as more spectrum is made available in other countries worldwide, we'll see that replicated. And those are not all the big mobile operators. They're the layer of system integrating communications and IT companies that are very active amongst the business markets around the world. Next slide, please. So what do we have now and what's coming next? So the data you've seen today is part of a database that's been collated and is now maintained by the GSA and available to members in the database format from the start of next month. We published our first report on private mobile networks earlier this month, and there'll be new data sets released and an update report next month with monthly updates after that. The database is expanding all the time with new entries, and very soon we'll be adding an interactive search as part of the GSA's Gambod database, and that will be coming very soon. We are keen to receive any information you may have to help us build our information sets so that we can share a more complete picture back with you. So please tell us about spectrum allocations, licenses, deployments, or innovative use cases, and you can send those to research@gsacom.com. Any contributions will be gratefully received. So that's given you a flavour of what we are collecting and what we are doing in the private mobile network space and the sorts of information we're going to be publishing. Thank you for listening. We're going to take questions in a minute. If you have any more to ask, please submit them now, and we'll do our best to answer them. In the meantime, thank you, and I'm going to pass you back to Joe.
Great, thanks, Simon. So at that point, I'll hand over to Joe Batt, President of GSA, who just a few words quickly about the Gambod database.
Hopefully that was informative for everybody, and thank you for your questions. I think we've got a few coming through that we'll get to in a moment. I just wanted to quickly go over what Gambod is. It's a search tool and R&D industry covering 4G, 5G devices, and then what networks are deployed, what technologies, and what spectrum is being used. And there are various search criteria. I'm not going to go into detail, but you can output in lists the data of your search or in graph forms. And as we said, this data is a background or the base for all of the reports that GSA is producing. We'd say we do offer this available as a discounted rate to members, to operators and regulators especially. So we have a number of regulators who get access to these reports and this data. I just wanted to pick up on one question that I saw in the chat around spectrum before we go to other questions that may be more relevant to Simon, and that is about how do we
Hi, Joe, I think you may be muted.
Well,
you good?
Am I okay?
Yeah.
Okay, thanks. So there are, so from a point of view of advocating spectrum for private networks, so the Spectrum Group is working on making additional spectrum available in the low band, mid band, and high band for 5G and for mobile in general. But we don't specifically advocate use cases like private mobile. Our position is that there are three options for private network deployments and licensing. One is for the enterprise or the third party to use licensed spectrum via the operator. The second is to have shared spectrum, maybe with the operator, and making that shared spectrum available. And we've seen some cases of that in the UK and other places around the world. Or dedicated spectrum, which is we've seen, as Simon mentioned, in Germany. And you could say CBRS is a similar situation in the US. So that's our basic position there. So with that, I think it's time for questions. Do you want to see what questions are available and consider those, please, Richard?